Hello, hi everyone. Welcome to the Student the Brand. This is our Sivasa. Today we are going to discuss about human eye and colorful world. So what is that? Human eye and colorful world. Okay. So in human and colorful world, we will discuss about human eye parts and function. After that, near point, far point, nearsightedness, farsightedness. That is nothing but refractive defects. So after that, we will discuss about colorful phenomena. Light passes through the prism and the light passing through the water droplet, and the recombination of spectrum of white light, refraction, atmospheric refraction. After that, scattering of light. So we will discuss all these points. We will discuss about all these points. Once again, what are the points we need to discuss in this chapter? Human eye parts and function. Human eye parts and function, like cornea, iris, pupil, verticimer, aquecimer, retina. So all these points. After that, we will discuss about near point, far point, nearsightedness, farsightedness. Okay, so all these points we'll discuss. Let's start. So yes, here human eye and colorful world. Human eye and colorful world. Colorful world. Human eye. Human eye. Human eye. Human eye. Human eye. Human eye and colorful world. Human eye and colorful world. Colorful. Okay. Colorful world. Human and colorful world. Okay. Yes. So now we will discuss. Okay. So human eye parts and function. So briefly we will discuss about human eye parts and function. So how to draw the human eye? So human eye is the most sensible and sensitive organ in our body. Human eye is the most sensible and sensitive organ. If you close your eyes, you can't able to see anything in front of us. Once you open your eyes, you can able to see everything in front of our eyes. Yes, yes or no? Are you agree or not? Are you agree or not? Yes. Now, how to draw the human eye, and they're mentioning the parts and their functions we will discuss now. So let's start. So here I'm taking the human eye like this. Like here I'm considering here also. Human eye, human eye, human eye, human eye, human eye, human eye. Okay, so human eye, parts and function. Everybody be ready for it. So I'm taking like this. This is a convex lens. Convex lens, convex lens, convex lens, convex lens. So after that we are connecting like this. What is one? Ciliary modules. Ciliary modules. Ciliary modules. Ciliary modules. Ciliary modules, ciliary modules, ciliary modules, ciliary modules, ciliary modules, ciliary modules. So here you can see these are ciliary modules like this. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Human eye parts and function. Human eye parts and function. Here we are discussing cornea, iris, pupil, cornea, iris. So here, na 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 na. Chun, 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 chun. Na 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 na. Na 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 na. Na 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 na. So cornea, iris, pupil, iris, pupil, aqueous humor, aqueous humor. Okay, so next one, vitreous humor. Ready? This is the vitreous humor. Vitreous humor. Vitreous humor, aqueous humor, aqueous humor, aqueous humor, aqueous humor, vitreous humor, vitreous humor, aqueous humor, aqueous humor, aqueous humor, vitreous humor, aqueous humor, vitreous humor. So, all of you listening here. So, listen here. Aqueous humor, vitreous humor, retina, optic nerve, optic nerve. Okay, so here you can observe these are the human eye, human eye. So you can observe here, human eye. So cornea, aqueous humor, pupil. This gap is called pupil. And iris, and here vitreous humor, retina, optic nerve, and here one more point is there. That is a blind spot. Okay, so what is people will do? So when light ray is coming, so most of the refraction takes place at this point. So when light ray is entering through the eye, so here, so this is the front layer, protective layer of the eye. So cornea, this is a cornea, front layer, protective layer of the eye. So this one, front layer, protective layer of the eye. Most of the refraction takes place at cornea. So coming to aqueous humor. So aqueous humor is a jelly type liquid present between cornea and eye lens. So it gives blood and nutrition to the central cornea. And coming to the iris. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris, actually this is also iris only, so we can connect. So this point, so this one is iris until here, and here you can see these are ciliary muscles. So this also ciliary muscles. Okay, ciliary muscles. So you can observe this one and this one, both are ciliary muscles. Both are ciliary muscles. So iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. So people will control and regulate the amount of light entering into the eye. People, you know, people, this is a people. This is a people. People will control and regulate the amount of light entering into the eye. People will control and regulate. People will control and regulate the amount of light entering into the eye. So iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. People will control the amount of light entering into the eye. This is a people. And coming to the ciliary muscles. So ciliary muscles which will hold the lens to adjust its focal length. When you are seeing a nearby object and far by object, when you are seeing the nearby object, far by object, so normally you can see in our mobile, we can able to zoom it or zoom out. So if you want to see nearby object, we can see. If you want to far by object, you can zoom, right? But here, so we can able, if you want to see nearby object, we can able to see. If you want to far object, we can able to see. How it is possible? So ciliary muscles will adjust the size of the eye lens. Size of the eye lens, that is nothing but crystalline lens. That is nothing but so crystalline lens, eye lens. So this is the, you can see. So we can't do like here. So better. Okay, so I am taking here. So these are ciliary muscles, right? These are the ciliary muscles. So I am taking, these are like this I am taking. So eyelens, 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 eyelens. So you can observe here, this is about ciliary muscles which will hold the eyelens, so that it can able to adjust its focal length. So if you want to see a nearby object as well as far by object, if you want to see nearby object as well as far object, so ciliary muscles will adjust its focal length, so that we can able to see. Yes or no? Eyelens, whenever light rays falls on it, whenever light rays falls on it or incident on it, it converge the light rays and make it falls at retina. So vitreous humor, this entire portion is filled by the vitreous humor. Okay, so this is the vitreous humor. Okay, so it provides sufficient force and pressure to maintain that shape. Okay, eyeball shape. So retina. So whatever the light rays are incidenting on the convex lens, that will be converged and meet at retina. So at retina there are two types of light sensitive cells are there. There are two types of light sensitive cells. Those are rods and cones. Rods and cones. So rods helps the intensity of the light. Cones helps the color of the light. Rod sense the intensity of the light. Cone sense the color of the light. Yes or no? So here you can observe. Sorry. So retina is a light sensitive screen. There are two types of light sensitive cells are there. Those are rods and cones. Rods sense the intensity of the light. Cones sense the color of the light. Rod sense the intensity of the light. Cone sense the color of the light. And so what type of image will form at retina? So real and inverted image will form at retina. That too 2D image that will convert it in the form of electrical signals that will pass to the brain. Brain will Brain will add the additional information. Additional information. We are seeing the object in 2D format. Okay, so 2D object we are seeing. So whatever the image is forming at retina, real and inverted. Whatever image is forming, real and inverted. That will be converted into signals that will pass to the brain. Brain will add the additional information. How much depth it is, how much width it is from us, how much depth it is, how much width it is, how far it is. All this information will be given by the brain. So whenever the object we are seeing, that will pass to the cornea, pupil, lens, retina that will convert into electrical signal that will pass to the brain. So brain will add the additional information. Okay, so brain will add the additional information, that is 3D information it will be given. Yes or no? Yes or no? Yes. So that is about retina. And coming to the optic now, as was mentioned, that image will be converted in the form of electrical signal that will pass to the brain through optic nerve. So blind spot, there won't be any images forming here. So there won't be any images forming. So no light rays will meet. It's a dark place. Okay, that is called blind spot. Understood or not? Of course it is very clear. So if it is very clear, click on like button. So do like, share and subscribe my channel. If you like my explanation, if you like the concept, if you understand this concept, click on like button. Just click on like button. That's enough. Simple, very easy, very simple. Click on like button. That's enough. So coming to the once again human eye. So human eye completely we are discussing about human eye in parts. Okay, first point is cornea. Cornea is the front layer, protective layer of the eye. Most of the refraction takes place at cornea. And next one, so aqueous humor is a jelly type liquid material present between cornea and eyelens. It provides blood and nutrition to the central cornea. Okay, so iris is a dark muscular diaphragm. Which controls the size of the pupil. People will control the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. So ciliary muscles. When you are seeing the nearby object or far by object, normally we can able to zoom out or zoom in mobile. Okay, so if you want to see nearby object, no problem. If you want to see far object, we'll zoom out, right? It's okay. So then we can able to see automatically. So here also we are talking about zoom in and zoom out according to the distance of the object, right? Yes, but in our eye, so immediately we can able to see nearby object as well as far objects, right? Yes or no? We can able to see nearby object as well as far object. How it is possible we can able to see immediately nearby object as well as far object, right? So because of the ciliary muscles will adjust the curvature of the eyelids. Ciliary muscles will adjust the curvature of the eyelens so that lens will adjust its focal length to see the nearby object as far object with the help of ciliary muscles. So whenever light rays falls on it, so convex lens will converge the light rays. And make it falls at retina. So this entire portion is filled with vitreous humor. Okay, vitreous humor is a jelly type liquid present between eye lens and retina. Okay, so it gives sufficient force and pressure to maintain that shape. And coming to retina is a light sensitive screen. What are the light rays are meeting at retina, so that what type of image is formed at retina? Real and inverted. What type of image is formed at retina? Real and inverted image will form at retina. So there are two types of light sensitive cells are there. Those are rods and cones. Rod helps the intensity of the light. Rod helps identify the color of. Rod help the identify the intensity of the light. Cones helps they identify the color of the light. Okay, so these are two light sensitive cells. And at retina, what type of image is forming? Two types of images. Sorry, what type of image is forming? Real and inverted. Real and inverted is forming. That image will be converted. That image will be converted in the form of electrical signal that will reach to the brain. So what type of image is forming? Real and inverted. That too 2D image. So that will be converted in the form of electrical signal that will pass to the brain through optic nerve. So brain will give the additional information, how much depth it is, how much width it is, so everything it will give. Okay, so yes, so here we are talking about retina and optic nerve. So through these nerves it reaches to the brain. Next one, blind spot. Blind spot, there won't be any light rays will meet. It is a dark place. Okay, so where nerves are nerves. Okay, so nerves, optic nerves are reaching to the brain. Okay, so this is about the parts and function. Next, so now we will discuss about near point and far point. So what is near point and what is far point? Na, 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 na. La 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 la. So near point, and far point. There are 2 points. Point number 1, near point. Point number 2, far point. Near point, and second one is far point. Near point. Near point is nothing but the minimum distance up to which a person can see clearly without any strain. So near point, the minimum distance up to which a person can able to see clearly without any strain is called near point. Coming to far point, the maximum distance up to which a person can able to see clearly, that is called far point. Near point is 25 centimeter, far point is infinity. Near point is 25 centimeter. Far point is infinity. What is range of vision? Range of vision. Range of vision. Range of vision is nothing but, so 25 to infinity. That is called range of vision. So the person can able to see clearly, distinctly, without any strain. So that is range of vision. A healthy person, normal person, the range of vision is 25 to infinity. 25 centimeter to up to infinity, the person can able to see clearly without any strain. That is called range of vision. Range of vision. Okay, so now near point. So a healthy person, normal person, the minimum distance up to which he can able to see clearly without any strain, that is called near point. So near point is 25 centimeter. Far point, so the maximum distance up to which a person can able to see clearly without any strain, that is called maximum point. That is called maximum point. So range of vision is 25 to infinity. And here one more point is there. So least distance of distinct vision. Least distance of distinct vision. So least distance of distinct vision, what is that? So the minimum distance up to which a person can able to see clearly without any strain is called least distance of distinct vision. What is that? What is the value of that? That value is 25 centimeter. 25 centimeter. So you can see this marker if you place in front of the eye. Can we, if you place very close to the eye, will you able to see until certain time? So you can see sometime, but after certain time, after certain minimum time, our eyes will get strain, our eyes will get pain. Why? Because so after until certain distance only, if you place certain distance from eye, we can able to see clearly, comfortably. So we can able to see sometime. So maybe 1 hour, 2 or 3, it depends. But if you place very close to the eye, very close to the eye, or less than 25 centimeters. So suppose less than 25 centimeter if you place, so it is not possible to see the object. Okay, ciliary muscles so cannot contract beyond the point. Okay, until certain point only it will contract and see the objects. So below that one it won't be. Okay, so because of that reason we can't able to see the object below 25 centimeter. So the minimum distance up to which a person can able to see clearly without any strain is called least distance of distance vision, that is 25 centimeter. Range of vision is 25 centimeter to up to infinity. Range of vision is 25 centimeter up to infinity. Okay, what is near point? 25 centimeter. What is the value of near point? 25 centimeter. What is the value of far point? Infinity. Range of vision 25 to infinity. Okay, so be very clear with that. So keep in mind all those points. Very, very important. Next one. Next. We are discussing about myopia. Myopia. Near distance we can see, far distance we can see. Myopia. For that correction we are using bro. What bro? For that correction we are using concave lens, concave lens. So myopia. Far distance, near distance we can see, far distance we can't see. For that correction we are using concave lens. Okay, so those points I frame in the form of song. Once again for you, let's listen. Myopia. Near distance we can see, far distance we can see. Myopia. For that correction we are using bro. What bro? For that correction we are using concave lens, concave lens. Yes, so now you can see normally, so when you are aging, our eye lens can't refract the light rays properly. Generally, so just before I explained with the help of diagram, human eye, when light rays are entering through the pupil, so whenever it falls on the eye lens, it converge and make it falls at retina. But so because of due to lack of refraction, means it won't happens properly. Okay, so refraction does not takes place properly. So due to refraction, so the light rays will not meet at retina. Okay, so sometimes in front of the retina it will meet, sometimes beyond the retina it will meet. Okay, so there won't be proper refraction. Okay, so due to these conditions, so some people can able to see near distance, some people can able to see far distance. Okay, so to correct these defects, we will use suitable lenses to correct these defects. So those are called refractive defects. So refraction does not take place properly. Okay, lens does not refract properly. Okay, so generally what happens, lens should refract properly so that the light rays will meet at retina. but it won't happen. So for that, what we'll do, we'll use lenses, suitable lenses, convex lens, concave lens. Sometimes both will happen, so like a myopia and hypermetropia together will happen. That time we will use double convex lens, bifocal lens, we can say bifocal lens, like that. Okay, upper portion concave, lower portion is convex, like that we will use. Now we can see, so myopia, just now I sang the song. Near distance we can see, far distance we can't see. Near distance we can see, far distance we can't see. For that correction we are using concave lens. Hypermetropia. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction we are using convex lens, convex lens, convex lens, convex lens. Means, so hypermetropia, we can see far distance, we can't see near distance. For the correction of hypermetropia, we are using convex lens. Now, so we'll draw the diagrams. I'll draw the diagram. Just follow that. Okay. So here, and so person is here. The person has myopia. So this is 25 centimeter near point, and this one is infinity. Okay. So 25 centimeter and infinity. So the person who has myopia can able to see near distance clearly. He can able to see clearly near distance, but he can't see the far distance. So he can able to see clearly near distance, but he can't see far distance. But between 25 to infinity, he can see somewhere. Between 25 to infinity, you can see somewhere. That is the far point of myopic eye. Far point of myopic eye. Okay. So now we will draw this. See. Okay. So one entire this scenario we'll draw in the format of diagram. So in the format diagram we'll draw. So just observe here. So 25 centimeter we can see. So infinity we can't see, but between 25 to infinity we can see. So this is also a defect only. Sir, why you are saying this is a defect? We can see, no? So we can able to see those objects. Okay. So the object is placed at this point. We can able to see. How can you say it is a defect? The problem is only that point only we can see. So we can't see beyond that point. Beyond the point we can't see. So this is also defect only. Okay. So generally, so we can see this point. We can't see this point between infinity to between 25 to infinity, somewhere at once. Okay, at one point we can able to see. So that point is far point. Okay, so we will draw that point. Okay, so observe carefully. So this, okay. Now, na 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 la 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 So actually this corner is very important. We have to draw properly. So make it proper curve. So I'm trying my level best to draw. Okay. So and the lens. So convex. So total eyeball and the lens must draw, and this curvature, that is, what is that? Cornea. And so fix it. Actually it is near point and here is a far point. From here you are taking the light rays. Okay. So this is the far point F, and this one is the near point. So as I mentioned, near point we can see. So infinity we can't see, but somewhere between infinity and 20. So I'll draw the same. So this point we can see. Okay, so this one far point of far point of myopic eye. So this is a myopia. So myopia. So now you can see. So this point we can see. This point we can't see. This point also we can see. First we'll draw this is the diagram, and second diagram, and third one is the correction. That is the order. So once again observe here. So first you have to draw this diagram, far point of myopic eye, and the next one, if the light rays are coming from this infinity, so where those light rays will meet, so we have to observe that one. And correction part we will check. So light rays are coming from this point, then those light rays are meeting at infinity. So here you can observe these light rays are meeting at one point. Here you can observe. So these light rays are meeting here. These light rays are meeting here. Meeting. Na 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 na. This is a far and near. Near we know that 25 centimeter. Near point is 25 centimeter. So far point. So this only far point of myopic eye. This is the far point of myopic eye. Okay, far point of myopic eye. Now, so next one. So this is the first one. Coming to the next. Okay, so like that, as I mentioned, so this one completed. First diagram is this one only, and we are drawing the next one. So next one you can observe. Next one how to draw. So I'm taking here. Okay, so now, so light rays are coming from infinity. If the light rays are coming from infinity means we have to draw with the dotted lines. Dotted lines. So dotted lines. Okay, I'm drawing with the dotted lines. Look on it. So I'm taking one. Okay, this is the near point. Near F. Okay, so where light rays are meeting. So if it is a defect means where light rays will meet. So beyond or in front, because we can able to see near distance. So somewhat we have to bend because at cornea most of the refraction takes place. Okay, and here you can observe. So what is this one? Myopic eye. What is one? Myopic eye. So do like, share and subscribe to Student the Brand. So you won't miss latest updates from Student the Brand. Okay, myopic eye. So now correction. Okay. So this also completed. As I mentioned. So first you have to draw this diagram. So from PowerPoint we can able to see light rays are meeting at retina. So if the light rays are meeting at retina means that's enough. We can able to see the object. But if the light rays are meeting in front of the retina, so this is the retina, in front of the retina only the light rays are meeting. So it is a defect or not? Definitely it is a defect. Okay. So we can able to see only near object. Now how to correct this defect? This is a myopic eye. So in front of the retina means we can't see. The light rays are coming from infinity, right? Infinity it is coming, right? So if it is infinity coming, we saw light rays are not meeting at retina. So then it is a defect. Okay. So now, so now you can see correction. Correction part. Third diagram is correction part. Third part is correction part. Okay. So just check once. Lens. What type of lens we are using? Concave lens or convex lens? What type of lens? Convex or concave? Convex or concave? Concave lens. This is a concave lens. Okay, concave lens. So here you can observe. So I'm taking the light rays here, light rays, light rays, light rays, light rays. So diverging. After passing through the lens, those light rays will be diverge. So again through the lens, convex lens, it will be converge and meet at retina. Those light rays will meet at retina. Okay. So those light rays will meet at retina. Now you can observe here. So this is a near point. So these are far point. So we are extending these light rays. These extended light rays are coming from the lens. So those will be meeting here. Okay. So now observe. This is about correction. Correction of myopic eye. Correction of myopic eye. Myopic eye. Okay, so these are the three diagrams. Very, very important diagrams. Very essential diagram. Compulsory damn sure question related to myopia, hypermetropia. Very, very important. That too very simple. You don't need to do any much struggle. It is very, very simple, like a cakewalk. Okay, so very simple, very simple, very simple. So I will tell. Okay, so you're eating like your most favorite food. How you feel? So it won't be much struggle, right? So like here also. So if you know this concept, these are very easy. So you no need to struggle a lot. So very simple. So remember this concept. That's enough. Simple concept, easy concept. Just to focus on this one. Okay. So 25 centimeter. Okay. So we can able to see near distance object. That is that we know that. And far distance we can't see. Infinity point we can't see. But between 25 to infinity somewhere we can see. Between 25 to infinity somewhere we can see. So what is that point? Far point of myopic eye. What is that point? Far point of myopic eye. What is that point? Far point of myopic eye. So for the first diagram is that one. First diagram you can see. So from this point light rays are coming after refraction. Those light rays are meeting at retina. So if we are able to see, means compulsory the light rays must meet at retina. That you have to remember. Okay, so there is another option. So if we are able to see that point, if you are able to see that particular object, means those light rays are meeting at retina. So compulsory light rays should meet at retina. And this one, why I am saying means this one and this one light rays should meet. So after correction anyway we are doing. And here in the second case, so if you observe in the second case, you'll get the causes also, causes of myopia. Okay, causes of myopia. Eyeball is too long, focal length is short. Okay, so point number one, causes they will give for 2 marks, causes they will give for 2 marks. Eyeball is too long, focal length is short. Second one is focal length is short. Focal length is short. Okay, focal length is less. So we can say less. Okay, focal length is less or short, we can say. So less, focal length is less, focal length is small. Like that also we can take. So by observing this second diagram is very, very important. Very, very important. Second diagram, if you observe, you will get so many points. Okay. So easily you can understand, easily you can remember. So usually you can get marks. So approximate minimum 5 marks. Expected question. Okay. So not only this one, related to this one more problem also will be attached. So here, so sometimes they will give 3 diagram and sometimes they will give last diagram. So draw the correction of myopic eye. And so for 2 marks question are MCQs, assessment reasoning, and so like this. So coming to here, in this case, so you can observe. So eyeball is too long, focal length is small. Okay. So because of eyeball, so eyeball is too long, focal length. So light rays are meeting in front. So focal length is less only, right? Okay. Sorry. Okay, so that's enough. So 4 point of myopic eye, and myopic eye and correction of myopic eye. Okay, correction we are doing. So what type of lens we are using? Concave lens. What type of lens it is? Concave lens. What type of lens it is? Concave lens. So what is this one? Myopia correction. What is myopia? Myopia is nothing but, so myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using. Concave lens, concave lens, concave lens, concave lens. Yes, okay. So that's enough. PowerPoint of myopic eye, correction of myopia. And here you can observe eyeball is too long, focal length is small. So these are causes of myopia. I hope it is very clear. So myopia, just remember, see, concept I am giving, song I am giving, just you can remember very easily this concept. Very in a simple way, easy way, clear way. Okay, so we can't able to forget about it. Okay, so like that it will be. So myopia song. So 2 lines, that's enough. Near distance we can see, far distance we can see. For that correction we are using concave lens. Just simple as like that. Okay, and here, so these are the diagram. You remember this concept. You will become like a pro. Okay, So now hypermetropia, 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 hypermetropia. Far a distance, far a distance we can see, near distance we can see. Hypermetropia, hypermetropia. Further correction, further correction. We are using convex lens, convex lens, convex lens, convex lens. So now, this is a song for hypermetropia. And hypermetropia, how it will be? So I'm saying here, the person is standing over here. So the person who has hypermetropia, so you can see here. So I'm taking like this. Hypermetropia, hypermetropia. This is the near point. What is the near point? 25 centimeter. Near point is 25 centimeter. Far point is infinity. So the person who has hypermetropia can see far point easily. Yes or no? So far point he can see easily. So leave it about it. So we can able to see this one. So but he can't see the 25 centimeter near point, he can't see. But one thing you can understand. So between 25 to infinity you can see somewhere. That point is called near point of hypermetropic eye. That point is called near point of hypermetropic eye. So that is called near point of hypermetropic eye. Hypermetropic eye. Now we will draw the diagrams. We will draw the diagram. How to draw the diagrams? Very simple. You keep this concept in mind. You remember this concept in mind. That's enough. Very simple. You don't need to struggle a lot about these diagrams. Those are very simple. I said to you, right, myopia. So how I thought myopia, how easy it is, like that. Here also same thing. Here also same thing. Hypermetropia also, it's very easy. Very simple. Very simple. Let's start hypermetropia diagrams. Okay. Hypermetropia diagram. Hypermetropia diagram. Hypermetropia. Hypermetropia. So this is 25 centimeter. And this one is infinity. Between 25 to infinity, you can see that is a near point. Near point of hypermetropic eye. Okay, so draw the diagram. So this surface is very important. So cornea, so draw properly, and the curvature, the bulged surface is very important. Make sure that you are drawing. The curve must be curved. You can't draw like a flat. So some people they'll draw like okay. So don't draw like that. So it won't look good. Okay. So it must be proper. It must be proper curve. It must be proper curve. Proper means proper curve. Okay. La 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 la. Okay, lens, come on, lens. So don't take too much time. So here near point, near point, near point, near point, near point, near point. So n dash. Okay. So n is a near point. So very important. You have to understand. So 25 centimeter and n dash is the near point of hypermetropic eye. Near point of metropic eye. Near point of hypermetropic eye. So you have to understand these points. Okay. So n is 25 centimeter and is the near point of hypermetropic eye. Okay. So be very cautious or very clear. Okay. So now I am taking the light rays. One light ray I am taking like this. How many light rays? One light ray I am taking. After that, how many light rays are required to form the image of the object? How many light rays are required to form the image of the object? How many? Two light rays. So that's why I am taking two light rays. Light ray number 1, light number 2, light ray number 1, 2. So after refraction, 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 light rays are meeting at a point that is retina. N dash. What is this one? Near point. What is this one? Near point of hypermetropic eye. Near point of hypermetropic eye. Okay. So n is the near point 25 centimeter, n dash is the near point of hypermetropic eye. Now, oh my god, so for drawing only one diagram it took so much place. So anyway, no problem, we will draw one more diagram. Okay, my god, it's actually, so place is too much it took. So if you drawing this like this, we can't able to draw three diagram. That's why I am erasing all the. Once again, I am erasing and drawing the diagram. Oh my god! Oh my god! It's okay, no problem. We can draw one more diagram. It's okay, fine. Just to draw. So diagram with the proper. So that's why you must plan for drawing diagrams on your paper, exam paper, right? So it must look good. It must be occupied sufficient space to draw all the diagram. If they give only one diagram, it's fine, no problem. If they give three diagrams, you must draw all three diagrams, okay? So plan properly, arrange the place, set the place for three diagrams. And I'm drawing like this. So near point n dash. So as I mentioned, so we can able to, so we can see this point. That point is n dash. Light rays are coming from this point. So light rays are coming from this point. After those light rays are meeting at retina. Where retina, where retina, at retina, n dash. What is this one? Near point of hypermetropic eye. Near point of hypermetropic eye. Metropic eye. Now, so we'll draw the next point. What is that? So here I am talking. So we can able to see this point. We can able to this point. We can't able to see this point. If the light rays are coming from infinity, where those light rays will meet? Where those light rays will meet? So now you can observe here. So I'm taking like this, like that. Dishka. What is that? Eyeball. What is that? Eyeball. Okay, these light rays, 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 light rays are. So you must to draw the curved surface. You must to draw the curved surface. Okay, you must to draw the curved surface. If curved surface is not good, so you will lose marks. If curved surface is not proper, if curved surface is not good, you won't get proper marks. It must be proper curved surface. Okay, next. Next. Yen dash, and dash. If the light rays are coming from N, if the light rays are coming from this point, where light rays will meet? Beyond the retina or in front of the retina? Are you listening? If you are there, just click on like button, share to your friends, ask your friends to join to the class. Now class is going on. What topic is myopia, hypermetropia, human eye in colourful board, CBSE grade-10 physics. Very important topic. 5 marks question. Click on like button, inform your friends, ask your friends to join to the class. What you are watching, just to do this point. Before this, before I am drawing, before I am going to draw this diagram, just to do that work. So click on like button, inform your friends, ask your friends to join to the class, share as much as possible, as many as possible in our WhatsApp groups. Ask your friends to join, they will also watch, right? They will also learn, right? Yes or no? Yes. So now you can see these light rays. So if the light rays are coming from 25 centimeter, if the light rays are coming from 25 centimeter, those light rays, where those light rays will meet? Beyond retina, where it is? Here it is. Okay, so one light ray I am taking. How many light rays are required to form the image of the object? How many light rays? At least you can comment now. How many light rays are required to form the image of the object? Minimum 2 light rays from light reflection refraction. From there onwards, we are studying light reflection diffraction. Minimum light rays are required to form the image of the object. At least how many light rays? Minimum are 2. Okay, so I'm taking 2 light ray like this. So that's why in your textbook also they given 2. Okay, so here. This light ray should meet at retina, right? So one. Okay, so here you can observe from 25 centimeter. This point is 25 centimeter. This point is 25 centimeter. What is this point? 25 centimeter. What is this point? N dash. N dash is the near point of hypermetropic eye. N is 25 centimeter. What is this one? What is this defect? Hypermetropic eye. Oh my god. We can't able to see because light rays are meeting beyond retina. Oh my god. What is this point? Hypermetropic. Ayyo, we can't have hypermetropic eye. Hypermetropic eye, we can't able to see. Why? Because light rays are meeting beyond retina. Ayyo. What we have to do? Oh my god, how to solve this? We can use convex lens. We can use convex lens. Convex lens. So convex lens, simple problem, easy problem. Why you are struggling so much? So it is very simple. Now we can use convex lens to correct the defect, right? Yes. So struggling so much, thinking the small problem into big in a maximum view, that is convex point of view. In convex point of view. So nothing, a small problem only. We will use convex lens. What lens? Convex lens. Convex lens. Convex lens. Convex lens. So if the light rays are coming from, so where light rays are meeting? Where light rays are meeting? Yeah, where light rays are meeting at retina. So from here I am taking N. This is N dash. Okay, so I am taking two light rays. Everyone be ready for it. And one more thing, you should take edges. You should not take in the middle. Again, you have to converge two times. Why? Here convex, here also convex. Okay, that's why we have to converge the light rays two times. That's why we have to take light rays out the edges. Edges. Like this, like this. So I'm taking light rays at the edges. Light rays at the edges again. Converge. Light rays again converging. Oh my god, light rays are meeting at retina. Here also light rays are meeting at retina. Yes. Light rays are meeting at retina. So now we can able to see the objects. So here how many light rays are required to form the image of the minimum 2 light rays are required to form the image of the object. So now you can see, now I am extending the light rays. You can observe here I am extending the light rays from the lens. Here also I am extending the light rays from the lens. From the lens you have to extend those light rays, those refracted light rays you have to extend, those light rays will meet at N dash. What is N dash? Near point of hypermetropic eye. So what is this one? Correction of hypermetropic eye. Correction of hypermetropic eye. Because of correction. What lens we use to correct this defect? Correction of hypermetropic eye. Correction of hypermetropic eye. What lens we use to correct the defect of hypermetropia? Convex lens. What lens we will use to correct the defect of myopia? Concave lens. Myopia, concave lens. Hypermetropia, convex lens. So here you can see from this point, very simple, very easy, very simple. You no need to worry about, you should not struggle so much to draw these diagrams. Oh my god, 3 diagrams are there. How to draw all these 3 diagrams? So we need to struggle a lot. No need to struggle a lot. You have to struggle little. What is that? Simple concept you have to remember. What is that simple concept? 25 centimeter in infinity. We know that hypermetropia means we can able to see 4 point. but we can't able to see 25 centimeter. We know that. But we have to know one more point also. We can see between 25 to infinity, that is near point of hypermetropia. Hypermetropia. From there we can see if the light rays are coming from that point, we can able to see. We have to remember that point. That point only our first diagram, our introduction. Our introduction. This is interval, this is the climax. Introduction. Opening is introduction, that is from end dash. From end dash, if the light rays are coming from end dash, we can able to see. So take the diagram, draw the eyeball, eye lens. So middle line, just you can draw n end dash. N is 25 centimeter, end dash is near point of hypermetropic. And so here you can observe. So we know that. What we know? So we can see infinity, we can't see 25. Okay, if suppose what happens, if the light rays are coming from 25 centimeter, what happens? If light rays comes from 25 centimeter, what happens? I want to know that. What is that? I wanted to know that. What is that? If the light rays are coming from 25 centimeter, where those light rays will meet? Yes, that is the second diagram. Okay, that is the second diagram. If light rays are coming from 25 centimeter, light rays will meet beyond retina. We can't able to see the objects. Nearby, those who has hypermetropia. For the correction of that defect, we are using convex lens. For the correction of the defect, we are using convex lens. So convex lens, we will place the convex lens. Light rays are coming from that point. After refraction, those light rays will meet at retina. Okay, so correction of hypermetropia. So myopia, hypermetropia. So presbyopia. Presbyopia means combined of myopia and hypermetropia. The person who has presbyopia, the person who has presbyopia can't able to see near distance as well as far distance. The person who has presbyopia can't able to see near distance as well as far distance. For that, we are using bifocal lens. Upper portion is, we are using concave lens. Lower portion is convex lens. Upper portion concave lens, lower portion is convex lens. Okay, so I hope it is very clear. So this is about human eye parts and function. Parts and function. Okay, human eye parts and function. Cornea, iris, pupil, ciliary muscles, aqueous humor, vitreous humor, retina, blind spot, optic nerve. So cornea is the frontal layer, protective layer of the eye. Most of the refraction takes place at cornea. Aqueous humor is a jelly type liquid present between cornea and eye lens. So it gives sufficient, it provides blood and nutrition to the central cornea. And iris is a dark muscular diaphragm which controls size of the pupil. Pupil will controls and regulates the amount of light entering into the eye. And ciliary muscles which controls, and so because of the ciliary muscles, so we can able to see the nearby object as well as far distance object. Okay, because of the ciliary muscles. Okay, so we can able to see the nearby object or far by object. So with the help of ciliary muscles, eye lens can adjust its focal length to see nearby object as well as far distance object. So that is about ciliary muscles. And eye lens is a convex lens. Convex lens. Whenever light rays falls on it, converge and make it falls at retina. Okay, that is about eye lens. And coming to the next one, People will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. And the next one, retina. Retina is a light sensitive screen where light rays will meet. There are two types of light sensitive cells are there. Those are rods and cones. Rod sense the intensity of the light, cone sense the color of the light. Rod sense the intensity of the light, cone sense the color of the light. Okay, rod sense the intensity of the light, cone sense the color of the light. Okay, so these are light sensitive cells. Next, so on retina, what type of image will form? Real and inverted. On retina, what type of image will form? Real and inverted. So that to 2D image. That will convert in the form of electrical signal, reaches to the brain. So it reaches to the brain through optic nerve. So brain will give the additional information, how far it is from us, how much far the object is placed from us, how much depth it is filled, how much height it is. Okay. Sorry. So all this information, all this 3D information will be given by the brain to us, so that we can able to see the objects in 3D format. Okay. So I hope it is very clear. So that's enough. And next one, optic nerve completed blind spot. So here no light will meet. Okay. So nerves are reaching to the brain. And the next one we will go to the near point and far point. Near point is nothing but the minimum distance up to which a person can able to see clearly without any strain is called near point. Near point is 25 centimeter. Far point is, so the maximum distance up to which the person can able to see clearly, that is called maximum point is, that is nothing but far point. Near point and far point. So what is the range of vision? Range of vision is nothing but 25 to infinity. Range of vision is 25 to infinity. Range of vision is 25 to infinity. 25 to infinity. That is called range of vision. Range of vision. Okay, na? So that's enough. Refractive defects. So when light rays falls on the lens, what lens has to do? It should refract properly. A light ray should refract properly by the lens. But if the lens, while aging, okay. So while aging, if the lens is not refract the light properly, if the light rays are not meeting at retina, then there will be a defects. There will be a defect. Okay, because of, so refraction is not happening properly. Okay, so there are 3 types of refractive defects. Those are myopia, hypermetropia, and presbyopia. Myopia, hypermetropia, and presbyopia. Myopia, if you see, the person can able to see clearly near distance. He can't able to see far distance. The minimum distance. Okay, so the person can see near distance. He can't able to see far distance. For that correction, we are using concave lens. I given song, so that song is very important. Once you remember one song, at least if you remember one song, automatically the concept is very easy. Those are myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So very simple, very easy. So myopia, near distance we can see, far distance we can't see. For that correction, bro, what, bro? Okay, so I'm asking a question. So to you, so what exactly we have to do? We are using concave lens to correct the defect. Myopia, concave lens. Hypermetropia, convex lens. That's enough. So one song you remember properly, automatically that concepts are very easy. Okay, so for remembering sake all these techniques I am giving, so concept, so according to the question, according to the problems, okay, so you have to write just why I am all doing all these methods to remember whenever we want to recall immediately. So just example is, if I ask so which lens we will use for correction of myopia, which lens? Concave lens. How we remember? By song immediately. So automatically that lyrics and the tune, if it is there in mind, automatically. And myopia means, so we can see near distance, we can't see far distance, right? That's enough. That's enough. Simple, very easy, right? Next, so now we are going to discuss about, already we discussed, that is next one is hypermetropia. Three diagrams as I mentioned. This concept, if you remember, very simple. If you remember this concept, so we can draw these diagrams like a small playing game. Okay, so like a your favorite, how you will eat your favorite food, so with a very interest, very anxiety, very, that's enough. So like that, so we can draw these diagrams very easily if you know this concept. This concept is very very important. Just know this concept, okay, and keep both the songs just in mind. Automatically you can recall the concept, you can learn the concept in easy. Okay, that's enough. Next one I'm going to discuss about light ray passes through prism. Yes, so normally you can able to see the rainbow in the sky, right? So after rain shower, means after rain, you can able to see the beautiful rainbow in the sky, right? 7 colors: violet, indigo, blue, green, yellow, orange, red. So in laboratory, so which device we use to split the light into 7 colors? Prism. Okay, so now we will see. So definitely 5 marks question, very important concept, just keep in mind. La 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 la. La 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 la. La 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 la. Na 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 na. Na 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 na. Na ni na ni na na ni na 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 na. Na ni na ni na ni na 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 na. So do like, share and subscribe to Student the Brand if you like the content, if you like the channel, if you like my explanation. So please click on like button, do share and subscribe my channel for more updates and for more classes and conceptual knowledge. Okay, so done, and this type of techniques. Okay, done. Now, so I'm taking prism. Say with me, learn with me, sing with me. Dispersion. 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 Splitting white light into 7 colors is known as dispersion. 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 Splitting white light into 7 colors is known as dispersion. 1, 2, 3, 4, 5, 6, 7, 7 colors. Those 7 colors will form like a band on the screen. So this is a band. So these 7 colors will meet here. Yeah. Those 7 7 colors are forming like a band on the screen. Arararararararara. Those 7 colors are violet, indigo, blue, green, yellow, orange, red. So I don't know those many colors. I'm using just one or two colors. So please adjust. Okay. So violet, violet, indigo, violet, indigo, blue, violet, indigo, blue, green, yellow, orange, red. With GR. Violet, indigo, blue, green, yellow, orange, red. Okay, so white light is passing through prism. It's split into 7 colors. Those 7 colors will form like a band on the screen. The splitting of white light into 7 colors is known as dispersion. Splitting of white light into 7 colors is known as dispersion. Come on, say with me, learn with me, sing with me. Dispersion. Dun, 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 dun. Dispersion. Dun, 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 dun. So no background music, no. So all those instruments. So one beat, one lyrics, beat. Dun, 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 dun. Okay. So when a light ray passes through the prism, it's split into 7 colors. Those 7 colors, okay. So those 7 colors is known as dispersion. All those 7 colors will form like a band on the screen. Band on the screen, that is called spectrum. Those 7 colors will form like a band on the screen, known as spectrum. Okay, so splitting of white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen is called spectrum. Okay, so this is about light ray passes through the prism, and if how it will form in the sky. Okay, so we'll draw with the water droplet. So this is the water droplet, water droplet, water droplet, water droplet, water droplet. So if the light ray passes through the water droplet, it's split into 7 colors. So those 7 colors will reflect back internally. So I'm taking here. So white light, white light, white light, white light, white light, white lights, which so red scatter or deviate least. Okay, so that's why it is at the top. So most violet. Okay, so so here you can observe now. Here you can observe now. When light ray passes through the water droplets, when white light passes through the white light passes through the water droplets, split into 7 colors. Those 7 colors will reflect back internally. Okay, so what is the phenomena involved in the formation of rainbow? What is the phenomena involved in the formation of rainbow? First one is refraction, dispersion, refraction, dispersion, internal reflection. Na 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 na. Internal reflection. Internal internal reflection, internal reflection. Ay, 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 ay. Oh. What is the phenomena involved in the formation of rainbow? What is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection, refraction, dispersion, internal reflection. Well, light ray is passing from 8 to water droplet. This is a water droplet. So completely inside it is water, right? So light ray is moving from 8 to water, it is bent. So that is nothing but refraction. It's split into 7 colors, that is a dispersion. So total light, internally reflection takes place, that is called total internal. Oh, internal, actually it is a transparent medium. So some of them may be observed and passes. So that's why it is, that's why we are saying internal reflection. So it's not total internal reflection. So internal reflection we are saying. So here once again, this one, what is this one? Light ray passes through the prism, split into 7 colors. So dispersion, splitting of white light into 7 colors. How many? 1, 2, 3, 4, 5, 6, 7. Here 7 are there, no? That's enough, no? 7 colors. Here also refraction, dispersion, internal reflection. Water droplet. Water droplet. Water droplets. Water droplet. Water droplet. Water droplet. Or water drop. Okay? Water drop. Simply we can say water drop. That's enough. Okay, done. So this is about refraction, dispersion, and internal reflection. Now we'll discuss about recombination of spectrum of white light. Sir, what is recombination of spectrum of white light? Recombination of spectrum of white light. Spectrum of white light. So everybody, are you listening? Do like, share, and subscribe to Student the Brand. You won't miss the latest updates. So click on like button once if you like the channel, if you like the content, if you like the way of explanation, just to click a like button, reach to the remaining students, those who want to learn, those who eagerly want to know the concept, want to learn and want to know, want to practice, want to improve their concepts. So they will get know our class is going on. Then they will join to the class. They will listen the class. They will understand the concept. They will practice. They will get good marks. They will do better. Right? Yes. Now, which one we are discussing now? Recombination of spectrum of white light. Recombination of spectrum of white light. Recombination of spectrum of white light. When light rays coming and incidenting on the... So this is the prism. Prism 1. Prism 2. So after incidenting, what happens? After the light ray will, what happens? So like this, again it moves. What just here you can observe here white light, white light, white light, white light, white light. So the outcome also, see here screen, white light, on screen also white light. Okay, so I have only a few colors, that's why I'm using only those colors. So better please adjust and follow. So here prism 1 or prism 2. So source, here source, source is nothing but the object which gives the light. Okay, so here you can observe from the source light ray is coming, that is white light. So after incident is split into 7 colors. Those 7 colors will form on the inverted position of the prism placed next to the prism one. Placed to the place next to the prism one. Okay, inverted position. If you place so two prism like this, we won't get it. Okay, so you won't get it. So Newton observed, did practice. Okay, so practice, that is, so he placed first one prism, so it split into 7 colors. Again he placed this, so one more prism near to the first prism, so same position. So but so you didn't get anything. Then so he placed the inverted position of the prism next to the first prism. Then he observed that white light is coming out. So white light came out. So that is, so here on the screen it is white light. Okay, this is called recombination of spectrum of white light. Recombination recombination of spectrum of recombination of spectrum of white light. Okay, recombination of spectrum of white light. So here you can observe here. Okay, so whenever light rays incident on it, it will split into 7 colors. The 7 colors will form on the inverted position of the prism. Again, so that's those 7 colors will be combined and coming out as a white light on the screen, right? So I hope it is very clear. So this is about recombination of spectrum of white light. So refraction. What is the refraction? The path of the light changes when it is moving from one medium to another medium, or the bending of the light ray at the interference of the two media when it is moving from one medium to another medium, or the direction of the light changes when it is moving from one medium to another medium. So like that, so many definitions we can give for a refraction of light. But so that is refraction. What about atmospheric refraction? Best example one example I will say. So there are two friends. One friend A is standing one side, so back of fire. So another person is standing here. So friend A here, friend B here. So friend B is seeing through the fire to the friend. Okay, so friend B is seeing friend A through fire. So what happens? The friend A image is flickering or moving like this. So why? So when he is seeing through the hot air, so the light ray is passing through hot air to cold air, again cold air to hot air. Then what happens? So here it is coming to medium. Then when, so we know that when light ray is moving from one medium to another medium, it refraction of light takes place, bending of light takes place. So that's why when we view through the fire, so the object is placed behind of the fire or so back of the fire, then it appears flickering. It appears like a flickering or fluctuating. Okay, so due to refraction of light. That is small, like a small example, like in your like a local wise. So if you take stars you can see from long back onwards. See, from far distance onwards, light is coming from the star. Okay, light ray is coming from the star. So it keep on changing its direction. That's why star appears twinkling. So actually the position will be there only because of the atmospheric refraction. Refraction takes place by the atmosphere. So that is called atmospheric refraction. Refraction takes place by the atmosphere. That is called atmospheric refraction. Because of the atmospheric refraction, so the stars appearing twinkling. So here you can see the person is here. Okay, so star is here itself. So when it is coming like this, so it is keep on changes its direction. Keep on changes it. So adjust with the diagram. So I know that star position like that. Okay, so actually, so but actually it's the apparent position. The apparent position of this actual position. So due to refraction, atmospheric refraction, the star position appears here. Okay, so that's enough. Next one. So one more. Even sun appears 2 minutes before actual sunrise, and even sunset also. So I will draw the diagram. You can observe here. This is about atmospheric refraction. Due to atmospheric refraction, it appears. So this is the Earth, and Earth atmosphere. This Earth atmosphere. Okay, so this is the origin, like this origin. So sun is here itself. This is the sun. So before sunrise, so sun is here. So when light ray is coming like this, when light ray is coming due to atmosphere, this is the atmosphere. Okay, so atmosphere, Earth atmosphere, due to atmosphere. Okay, due to atmosphere. So the person is standing here. The person is standing here. Oh my God, diagrams are not coming proper. So yeah, person. Okay, so this is origin, sun. So light ray is coming from the sun due to here, due to atmosphere, due to atmosphere. So the position of the sun appears here. Actually, this is actual position. No, this is apparent position. Apparent position. This is actual position of the sun. Actual position of the sun. Understood? This is actual position of the sun. This is apparent position of the sun. When light ray is coming from the sun due to atmosphere of the earth. Okay, earth atmosphere. So at this point it bends. So because of that reason, it appears here. Okay, so 2 minutes before advanced sunrise, means advanced sunrise and delayed sunset. Okay, so early, like 2 minutes early it will come. So after that, after sunset also still it appears. So that's why, so 2 minutes advanced sunrise and 2 minutes delayed sunset. So that question also there, very important question. So just focus on it. So 3 marks question, expected one. And okay, so one question asked. So why it is red color? So red light travels. So red color has longer wavelength. So it travels long distance. So morning time and evening time. So this distance is long. So large compared to remaining distance. Okay, that is the reason. So when light ray enters, okay, light ray start rising. So from here to here, distance is long. That's why red light travels longer. That's why it looks so red color. Okay, so red has more wavelength compared to the remaining color. That's why it travels long. So we know white has split 7 colors. So one more point is the scattering of light, that I will explain while explaining scattering of light. So we'll get all the point. But okay, still I will explain here. When sunlight, okay, so due to atmosphere, so scattering of light takes place. All the colors will be scattered away. Only red color have longer wavelength. It travels long distance. That's why it appears red color during morning time and evening sunset also. And the remaining time blue color. So blue color has shorter wavelength. It scatters fast. So immediately as soon as sun releases the light, so because of the atmosphere, so blue color scatter the most. That's why it appears blue color. Sir, one more question. During noontime, it appears white color. So why? So here the particles present over here, the particles in the atmosphere, what are the particles are present? So are equal size. So that's why whenever light releases, anyway it is here, sun. So whenever light ray comes, it scatters the light equally in all directions. Light will be scattered in all directions equally. Then everything will be mixed. It appears white color. So during noontime it appears white color. During evening time and morning time and evening time. Morning time and evening time it appears red color. Remaining time it appears blue color. Even deep sea also it appears blue color, because So due to scattering of light. Sir, what is scattering of light? You're saying scattering of light, scattering of light. So here position. So you have to remember one point. So position, upper end position. So you can see this is the sun here. Actual position of the sun. Because of the atmospheric refraction, early sunrise will happen. That is why 2 minutes advance sunrise and 2 minutes delay sunset. So due to atmospheric refraction. So positions, upper end positions. So due to positions means atmospheric refraction. Positions means atmospheric refraction. And due to colors. Colors means scattering of light. So blue color, like a white color, like a red color, scattering of light. So now one thing I will tell. Scattering of light is nothing but the re-emission of light in all directions with a different intensity. Okay, so light ray is coming from the object, okay, like a source. So it falls on the particles. It falls on the particle. Sorry. So it falls on the particles. So the particle size is comparable to the, if the particle size is comparable to the, if the particle size is comparable to the wavelength of the light incident on it. Okay, I will explain with the help of diagram. Just observe here. So here you can see, so this is the particle, so light ray is coming, this is the incident. Normally wavelength, what is the wavelength? The distance between two consecutive crust or two consecutive trough. So this is the crust, trough, trough. Upper portion is called crust, lower portion is trough. So the distance between two consecutive crust is called wavelength and two consecutive trough is called wavelength. Okay, so if the particle, so this is a particle, okay, this is a particle, light ray is incident, light ray, so I am taking this is a light ray. If the light ray is incidenting on the particle, light ray, this is a light ray, okay, light ray I am taking. So wavelength is nothing but the distance between two consecutive crust or two consecutive trough is called wavelength. So this is the light ray incidenting on the particle. This particle size is comparable to the wavelength of the light incident on it. So this wavelength is comparable to the particle size. Then this particle will absorb those light. Okay, will absorb that light and so re-emit. Okay, re-emit in all directions. Re-emit in all directions with a different intensity. With a different intensity. Okay. So once again, so this is a particle, this is a light ray. So wavelength is nothing but the distance between two consecutive crust or two consecutive trough. Okay, this is called wavelength. This is called wavelength. When light ray is falling on the particle size is comparable to the wavelength of the light incident on it, then the particle will absorb that light, and emit in all directions, with a different intensity. So that is called scattering of light, re-emission of light in all directions. So already light is coming down here, re-emission of light in all directions. It is not only one direction. Okay, you can go in this direction only, you can go in this direction only. Particle is not saying to the light rays, okay, so you go only this direction, so you should not go that one, that is not ours, so you don't go that side, only go this side. No, there is no restriction like that. Okay, so light ray will move in all directions. So re-emission of light in all directions with a different intensity. Okay, so you go only with 20 brightness, 30 brightness, 40 brightness. In our mobile we can increase, right, brightness. So it is not like that. So in all directions with a different intensity, that is called scattering of light. Scattering of light is nothing but re-emission of light in all directions with a different intensity is called scattering of light. Due to scattering of light, so you can observe all the colors. Okay, so because of this scattering of light only, so all colors we can able to see. And one more thing, Tyndall effect. So one more effect is the Tyndall effect. What is that? So Tyndall effect is nothing but, so you can see when you open, so in the early morning when you open the window, say beautiful sunrise falling on the falling on the room ground. A beautiful, right? How it is happening? And you can observe that dust particles are flying very happily. Okay, dust particles are flying very like a beautiful scenario. How it is happening? Because so light ray is passing through the colloidal solution. If the light ray is passing through the colloidal solution, the light ray will be scattered by the colloidal solution. Light ray will be scattered by the colloidal solution. Okay, means scattered in all direction, means so it moves in all directions with a different intensity. Okay, so that's why that Tyndall effect is nothing but the path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through colloidal solution is called Tyndall effect. And you're not only here when you're trying the dense forest and narrow beam of light ray is falling on the ground. So on the falling on the road, you can observe that one, and you can see like on trees if you're going on the road, so completely filled with trees, then in the middle one or somewhere, so narrow beam of light is falling. Okay, so because so that beam we can able to see clear the particles. Okay, so this is due to Tyndall effect. And you can observe the laser light, red light, it is falling, it is passing through the water, so you can able to observe clearly properly the particles present in the glass, so only that light passing path. Okay, so this is all about Tyndall effect. So that's enough about like a human in colorful world. I hope we covered all the topics. Right from human eye, parts and function, cornea, everything, and myopia, hypermetropia, presbyopia, and one more thing, cataract. Cataract is nothing but when you are getting old. So when the people are getting old, that time it is a milky and cloud will form on the eyelids. Okay, so you can observe milky and cloud will form on the eyelids. So due to aging. Okay, so to how can we remove that one? By cataract surgery. That is but a laser surgery. By laser surgery only we can remove that one, cataract. And one more thing, astigmatism. So some people can't able to see the horizontal and vertical lines properly. By using suitable cylindrical lens, we can use the we can correct the defect. So these are the extra points you can remember. Okay, and next one, so we can go with that myopia, hypermetropia, presbyopia, cataract, astigmatism. After that, one more point, we can go with that. That's enough. That is about eye related concepts. Next one, prism. Prism, splitting of white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen is called spectrum. Okay, so after that we will discuss about rainbow formation by water droplet. So refraction, dispersion, internal reflection. So after that recombination of spectrum of white light. After that we'll go with atmospheric refraction. So why star, and one more point, 3 marks question, why stars are twinkling, why planets do not twinkle. Actually stars are coming from far, at the same time these are illuminate object, means it gives its own light. So it's coming from far distance, keep on refraction, atmospheric refraction takes place, that's why it appears twinkling. Where planets are minute sources, small particles, small sources, even though it won't give the light, but it reflects the light. So one place it is bright, one place it is dark, like that everything will be nullified, means cancel everything, so then we can't able to see. So planets does not twinkle. Okay, this question also will give, it's very important. So why stars twinkle, why planets do not twinkle? 3 mark question, very important, so keep in mind. And next one, near point, far point, 1 mark. So combine 2 marks, near point and far point. Compulsory myopia, hypermetropia diagrams you need to practice, because 5 marks question, damn sure question, 5 marks. Okay, so myopia and hypermetropia. After that, we will discuss about presbyopia. What type of lens? Bifocal lens. Upper portion is concave lens, lower portion is convex lens. And That's enough. Scattering of light, scattering of light. So conditions means if the size of the particle is comparable to the wavelength of the light incident on it, then it absorbs and re-emit in all directions with a different intensity. So scattering of light, so very important, and condition also keep in mind, because assessment and reasoning type questions may give, or MCQs also they may ask. And this concept explanation, like 2 marks, for 2 mark question, it's very important, scattering of light. And coming to atmospheric refraction, number of questions are there, like advanced sunrise and delayed sunset, very very important for 3 mark question. And the diagram, especially diagrams, whatever we practiced in the chapter, all diagrams compulsory how to practice, very very important. After that, Tyndall effect, so that's enough. So I hope everything is completed. Explanation all the points. So thank you so much for joining and attending and listening. So maximum points we discussed. If it is anything left, let me know. So thank you so much for joining and attending and listening and supporting me. So do like, share, and subscribe and subscribe my channel. Okay. So inform to all your friends. Inform in all groups. Okay, so let them know your physics class is going on. Siva sir is teaching from Student in the Brand channel. So let them know. Let them know, everyone. Okay, so for first from your end, so please like, share, and subscribe my channel. So then automatically reach to the remaining one. Okay, thank you for supporting those who subscribe. Thank you so much. Those who are going to subscribe also, thank you so much. So this is your Siva sir from Student in the Brand. Okay, so next class, next with the next topic, with extraordinary topic will come in front of you. Okay, so thank you so much. We'll see you in the next class.